if two chords intersect in a circle, then the products of the measures of the segments of the chord are equal. So you're just multiplying the ones that come from the same chord, like AB times BC is equal to EB times BB. Alright? So you're just multiplying AB. So it's kind of like 1 times 2 is equal to 3 times 4. I'm just like numbering it. I'm not like saying that's equivalent.
Shut up,
Wait. Wait.
1 times 1 equals 1 times 1.
a bad day.
Here, let me put letters in there. W, X, Y, and Z. So W times X. There. Is it easier if I put letters in?
No,
Yes, because they don't have any.
It's like 3 times 4 is 4 times 3.
Per Jordan's logic, those don't equal each other either.
Okay. Now,
You gotta try.
Now the reason, just not that we don't have to go through a proof, but this proof would involve similar triangles. For example, if I were to join these here, we're basically saying these segments are proportional to each other. Okay, so that's actually how you end up with this times this equals this times this. Okay, so let's look at. So the first one here, we're missing AE, so it's just X times 6 equals 3 times 4. So it doesn't get much easier than that. X equals 2. Okay, the next one, right, has a little bit more involved with the algebra, but still, it's not too bad.
I think I know how to set it up.
Yeah, when you say spoil, it's
I say no.
It is.
So what do I call it?
It is not factor.
Distribute, I mean.
Distribute is fine.
Foil makes me just uncomfortable.
I've always heard.
All right, go ahead and multiply this out, guys.
I did.
We're trying to foil each other.
I got
I'm already
that.
on example 2.
Equals.
X equals 3.
Wait, I have that.
I'm just teaching this to myself at this point. It's a lot easier.
X squared plus 8x plus 12.
All right. Okay, so in example 2, the true shape of a rainbow is a complete circle. Okay. So, however, we see only the arc of the circle that appears above Earth's horizon. What is the radius of the circle containing the arc of the rainbow shown?
We have to find the radius of the circle. We have to draw a circle.
Okay. So,
Just cut the radius.
so if this is 5, this is 2.5, and this is 2.5, right? Picture this, if you can kind of imagine the circle continuing. What you would basically have, let me show, on a smaller scale. Okay, guys, can you just relax? This is 0.7, and this is 2.5, and this is 2.5. And what we want to do is we want to figure out basically the part that's hidden by the Earth, okay? Because if we can figure this x, then we have the diameter, right? So I'm going to take 0.7 times x is equal to 2.5 squared, or 2.5 times 2.5. So 2.5 squared is 6.25. Divide by 0.7, and we get 8 we'll say about 9.3. Okay. I drew it small. I drew it smaller.
Why are we doing Yeah, why do we need to do
Because
that?
it's just what we.
Okay, we've
Oh,
only learned
so
one
that's how
theorem
it
today.
connects to the
Yeah, but I
line.
just want to know why we need to do that. 'Cause it says what is the radius of the circle? So why didn't we just say 2 point?
Is 2.5 the
It's
radius?
not the whole radius.
No.
I see what you did there.
Okay, guys, we're not done with this example. What's the diameter of the circle?
You do.
What's the diameter?
5.
It's 0.7 plus.
It's 9. Oh, it's 9. That. No, it's not 9.
It's not 9.
It's not 9.
So it's 8.93.
9.63.
No.
9.67.
Okay. And then what's the radius?
So why is it 9.6?
Half of that.
Right, half of that.
So
Out of curiosity, why is that 9.63? Oh, it's not times. It's not plus 0.3.
We're good? Okay. So what we had to we had to visualize a big, gigantic circle that was mostly hidden. We had to use that property where if you have the two chords and their segments, if you multiply them together, they're going to be equal to each other. Then we were able to figure out all the way across, which would be the diameter, and then just divide that by 2 and we get the radius. Questions? Because 2.5 isn't the radius. This doesn't look like, that's not the center of this hidden circle. Okay, well maybe we can come back to it if you need more.
After he figures out.
Okay, let's look at a couple definitions. We have secants. Secants have to what? They have to intersect the circle at 2 points, right? Now, we have different parts of the secant. We have what are called external secant segments, and then we have the entire secant segment. So, this whole thing, like AC, is the entire secant. Also, AE is also a secant segment. If we think about what does external mean?
C doesn't end. Oh wait,
Just the segment. Just the segment. What when we think of something being external, we think of it being outside. So what part is outside? AD and AD. Those are external secant segments. We need to understand the whole secant segment versus the part that's just outside, because we need to be able to identify both parts for the next theorem. Okay? Okay, so if we have two secant segments that intersect outside of the circle. Now, we already learned about the angle measures, right? It could be half of the big arc minus the small arc. But now we want to talk about the actual length of the segments. So it sounds really confusing, but it's not that hard. It's just, again, it's just multiplying segments together. So what we're going to do is we're going to take the product of one of the secants. So what would be one of our secants? AC.
So it's not measured to it.
Right, so notice I'm not going to put a little segment line above because I'm talking about the measure of that segment. So I want to multiply AC by its external secant segment, which is AB.
Oh,
And then the same, exactly, so it's going to be the same thing on the other side. So this is going to be equal to the other secant segment, which is AE, times its external, which is AD. Yeah.
Coincidence.
I think that is coincidence. there yet. Oh, we got that. Okay, so we're gonna take a secant times its external, and then take the other secant times its external. Does that make sense? So the-
Yeah.
Basically, the whole thing times the part outside equals the other whole thing times its part outside. So, it's, you wanna be careful. Like, yeah, when you look at that entire segment AD, it's, you have to add the segments together, right? So it's x plus 5 or 5 plus x. And 7.5 times 4.5, or sorry, not times, plus. Well, no, you have to figure out what the whole piece is first, because what's the entire secant? The one on top, it's going to be 5 plus x times, what's the part that's outside? 5. And then the other secant segment is 12 times, what's the part outside? Good. Okay, so go ahead and solve that. Are we okay with that? Oops. So we got x equals what?
13.
Good. We're okay with this? Okay, so our next one looks almost the same, but instead of two secants, we have a tangent. JK is the tangent.
Do you understand our teenage?
No idea what you're talking about.
JK, and another is what us teens say for just.
I think I might have heard that a couple times. Believe it or not, it was even, the lingo when I was in
I used to read it.
Jordan!
My grade one,
JK was not.
and I thought it was so cool that it didn't in like third grade.
Okay, so this one is just a little different because of the tangent. So the tangent doesn't have two parts to it, right? The secant segment does. It has like a part outside and a part inside. So when we have the tangent, we're going to square it. So it's going to be
How did anyone think of this? Like, honestly.
JK gets squared, and it's going to get multiplied to the secant, which is JM in this case, times what's external? JL. So again, this one's going to be the tangent squared is equal to the secant times its external.
Why would it
Not.
be squared? Because if it was a secant and it was, okay, never mind.
So the tangent, why is it squared?
Yeah. So I was just thinking that like if it was a secant and it enters like 3 points and the external one times the entire segment.
Again, it has to do with similar triangles.
Okay.
So I could draw you similar triangles, but you're always going to have, it's like tangent times tangent equals the secant times its external. It's kind of like, so to take the, we can't just have one thing being equal to the product of two. So it's like tangent times tangent. Yeah.
I tried to do this problem like as we were talking about it, something is like trying to figure out an answer, but it won't stop.
So you might have to use quadratic formula. It's right there if you forget it. Okay. So what would this look like for number 4, example A?
Well, it'd be 16.
So it'd be 4 squared equals, what's the entire secant? Be careful here.
2x plus 2
Good, 2x plus 2.
times x.
So we're going to have 2x plus 2 times x. Okay. So we have 16 equals 2x squared plus 2x. Now what? This,
Yeah.
Now 2x squared plus 2x minus
right.
0.
I'm going to move everything to one side first. And I could try to factor it the way that I see it, but I notice that everything is divisible by 2. So I would basically divide by 2 to make it a little easier, to see if that helps. Okay, x squared plus x minus 8. The problem is that it still doesn't factor. There's no two numbers that will multiply together, right? So we're going to do, right? So it's negative b. B is the coefficient of the x, so it's negative 1 plus or minus b squared minus 4.
Wait, where's negative b? Where do you see that? Where's b?
B is 1, and so is a. Okay, so remember, if there's no coefficient, or if you don't see a coefficient, that means that there's a 1. A, B, C. So negative b. Okay. So x is equal to negative 1 plus or minus. Now this will give us a positive 32 here. So when we add 1, we get 33 under the square root. Well, because I just multiply these. So I see a negative and a negative, I get 32, and that's going to be 1. Now, I don't need you to change it into a decimal unless you want to, but this isn't the final answer. There's one thing that we have to consider. If this was a negative 1 minus the square root of 33, that would make this whole thing positive or negative.
Positive. Negative.
It would make, if you have a negative 1,
Minus 33 is going down, guys.
it's negative. So, could x be a negative value?
No, you have to add. So it has to be negative.
Because if we look back at this, if we were to plug in a negative number, it couldn't be, this can't be negative. So we just want, take away the negative part, it's really just negative 1, oops. It's really negative 1 plus square root of 33 all over 2. If you want to change it to a decimal, that's fine. But you can also leave it. All right, let's see if we can set the next one up, and then you guys have time for homework, which is nice. What's the entire secant segment? Good. Does somebody want to do it?
Try to do it. I'm gonna do it then. Okay. You have to multiply it again times x. That's what they did wrong. What, Miss Casey? What did it do? Oh, right here. Why is it doing that? What? Every time I put my thing there, it went down.
Oh, that's good. Maybe you're touching this.
Why is it 2x and not x squared? Why is it 2x squared? What?
What? Now you're confusing me.
You're supposed to add
Not that.
x plus 4, and then you multiply by x again.
Oh, I'm doing it wrong again.
Okay, what do you guys think?
Well, I did it. 48.
Equals.
Then I set it up wrong again. So I'll let you know. I can't really do problems.
Do we have to do the other one again?
Yeah. Now I have to think about
What do you do after
it.
that? No, I don't.
What is the factor? God, I haven't even thought about it. Yeah.
We have to do after that.
Hold on.
Ooh, you could take a 2 out, and then you
We
go.
already did that. You
Oh.
can.
So you could.
We're trying to factor it.
We're trying to avoid the
Oh,
quadratic
cool. Let's
formula,
do
so.
5.
You can't.
5 and 10 doesn't work.
That's
You
enough.
can't factor it?
We get the point. We don't have
You
to.
can't factor that?
I don't think so.
And then 5.
So are we just doing the quadratic formula?
Okay, so does it not factor?
Does it not factor again?
I don't know. What is it? Is it 50?
Yeah, I don't think it factors.
So what goes into 50?
25.
25,
And
2, 10, and 5.
Doesn't work.
Other numbers do
Oh, the
12,
quadratic
5.
formula works.
Yeah.
We get the point. Do we have to do it?
We get the
We
point.
get the point of these problems.
No.
No, I like these.
Gabby, be quiet.
It's just like you just plug in the numbers.
I don't understand how you do that.
X.
Where did you get -2?
That's the, it's just here.
No, it's supposed to be positive too. Oh, no, it's negative.
It's, no, it's negative.
Wait, where'd you get negative?
It's always gonna be.
Because it's negative D plus all over 2.
All over 2 times 1. Oh my god, this takes so long.
4
So you didn't know what you got yourself into there, did you?
No, I didn't. And I completely regret.
Jacob out.
Okay.
Why is
I
it
got
negative?
-96.
Why is 50 negative?
Minus
Because
I
it's
got
a minus.
negative.
200. It's 4 minus
Because when
200.
you subtract
Oh,
100,
so it's
it becomes a
196.
Oh.
Negative
Oh
196.
wait, no, it's 4 plus 200 because negative times negative.
Yeah, Jordan.
So it's
204.
All over 2. Rowie, move.
So it should be negative 1.
You frustrated me.
Plus or minus.
You can reduce square root of 204.
It's negative
to what?
Oh.
I completely regret volunteering for this one.
Because then it doesn't look good.
Really, Jordan?
So
It has to be positive. So is it just.
Now what do we
Oh, jeez.
square root of 204. It's just only 4.
Wait, how did you get negative?
I want to go home and read my book.
Oh, it's negative 1.
So it's -1 plus or minus the square root of 51. But we don't want the minus because that'll make it negative.
How did you get
rid
that?
of all the twos.
That's what I.
Oh my god.
Homework.
Okay, so let me bring the textbook up when Jacob is finished writing that.
Is plus or minus still?
Wait.
No, take away the minus because that's going to make it negative.
Never
so.
mind. Okay.
Take away
Oh,
the minus,
God.
It's not negative.
Yeah, because one might.
completely regret volunteering for that.
But you did it.
But you
Good
wrote
for you.
negative.
No, he crossed. No, he just.
It was an accident.
Wait, why is it still square root?
Oh.
I like touched it.